Happy day, children. So last PPT we have seen about how the various scientists has proposed the structure of an atom. So we have learned that the discovery of subatomic particles like protons, electrons, neutrons, it led to the failure of Dalton's atomic model. We know that different models proposed by various scientists. Okay. Today we are going to see about atomic number, mass number. We know that periodic table, atomic number. So periodic table, it is arranged on the increasing order of atomic number. So atomic number is nothing but it is the total number of protons that is present in the nucleus of an atom. So atomic number is nothing but the number of protons and it is represented by the symbol Z. Okay. So atomic mass. How will you find out the atomic mass? Atomic mass is nothing but the sum of neutrons plus protons which are present inside the nucleus. So mass of electrons will not consider while we are calculating the mass of an atom. Only the mass of neutrons and protons are considered because the mass of electron is very negligible. Because since the electrons are the lightest particle, their mass we will not consider. So it is also known as mass number and it is denoted by the symbol A. So if protons and neutrons it is together, it is called as nucleons. Okay, generally it is represented, if any element it will be represented by the symbol Z, okay, Z and X, A. X always atomic number we will represent below and A it is the mass number. This is the way to represent the element. Okay, so down X represents the atomic number. So the atomic number, it denotes the position of elements in the periodic table. So mass number is nothing but number of protons plus neutrons. For example, hydrogen, 1 means 1 is atomic number and this one is atomic mass. For example, if you take oxygen, it is 8, it is 16. So atomic number is 8, mass number is 16. So how will you calculate that? So number of protons, atomic number is number of protons. So it is 8. If you want to calculate the number of neutrons, how will you find out? Mass number minus protons. So 16 minus 8, so it is 8 neutrons. Next, isotopes and isobars. Isotopes. Isotopes means the atoms of the same element with the same atomic number but different mass number. If you take example, hydrogen, isotopes of hydrogen, 1H1, 1H2, 1H3. All the three isotopes will have the atomic number same. Only mass number differs. That is the atoms of same element. That is very important. That is having the same atomic number but different mass number. This is the isotopes of carbon. Chlorine means it is 35, 37. So these are under isotopes. Isotopes only it will have the similar chemical properties. Only their physical properties will differ. Isobar. Isobar means the atoms of different element with a different atomic number but same mass number. That is called as isobar. Example, argon and calcium. Argon atomic number is 18. Calcium atomic number is 20. But both have the mass number 40. So how will you define isotope? Isotope means atoms of same element that having the same atomic number but different mass number. Isobars means atoms of different element with different atomic number but same mass number. That is called as isobar. What are the uses, applications of isotopes means it is used in isotope of uranium, it is used in nuclear reactor, isotope of cobalt, it is used in the treatment of cancer, and isotope of iodine, it is used in the treatment of goiter. Next, the arrangement of electrons. While I am teaching Bohr's model itself, as I told you, the maximum number of electrons in a shell, it can be given by the formula 2n square. N is the orbit number or the energy shell or the energy level. N is equal to 1, 2, 3. So the maximum number of electrons can be found out using the formula 2n square. So a K shell can have maximum 2 electrons, L shell can have maximum 8 electrons, M shell can have maximum 18 electrons, N shell can have maximum 32 electrons. So the maximum number of electrons, though it has 18, it can only accommodate 8 electrons. If it attains 8, it attains the octet configuration. After that, the chemical reactivity is very low. Okay, so until the inner shell, K shell is filled, it cannot move on to the L shell. First the inner shell has to be filled, then only we need to move on to the next energy shell. So these are the various energy schematic diagram. For example, if you take hydrogen, it is the K shell, so only one electron, so we will keep it here. So if you take boron, 5, right? So how will you write the electronic configuration? K, L, M, N. K shell maximum it can have 2. So only 2 electrons we have filled. And then it has 3. So 1, 2, 3. So until L shell it can accommodate 8 electrons. So like this it keeps on going. Valence electrons. So what is valency? Valency is nothing but the electrons which is present in the outermost shell. That is called as valence electron. So that is also called as valency. Valency will only decide the combining capacity of the atom. Okay. So for example, sodium if you take 11. So how will you write the electronic configuration? It is 2, 8, 1. So outermost electron here it is 1. So this is the valency. So for sodium valency is 1. So the electrons which take, so the valency only will decides the how much atom it can lose or gain. It decides how much electrons it can lose or gain. Okay, so the valence electrons will be in the outermost shell. One important rule: until 4 you can write the valence shell as such. If it is more than 4, you need to minus from 8. 8 minus number of valence electron. For example, if you take oxygen, it is 2, 6. If it is more than half filled, you need to minus from the 8. So 8 minus number of valence electrons.